Hey guys, this is a quick video to help you with gene mapping for the exam. First thing we got here is you'll see that we have genes and the relative crossover distances between them. And as you already know at this point, percent crossover is equal to the number of recombinants. And so that was already figured out. And so basically now what we have to do is we have to actually map the chromosome. Where are these genes in relation to each other? So you really can start anywhere, but you want to start with 3 reference points. So if we just take like A and B, and so the first thing we can do is just put, for example, A here and B here, and it says A and B are 1.5 map units apart. Well, that's easy. Well, what about C? Well, A and C is 2.5. So C could be on this side, right here, or C could be on this side. And to figure it out, we need to figure out how far B is from C. So we see that B and C are 1 apart from right here. So therefore, that tells me that C has to be right here. Because now you can see that A to C is 2.5 and B to C is 1. So far that works out. Then we can add yet another one. Let's do A to D. So A to D is 0.2. So it's either going to be right here or it's going to be right here. So if we take a B to D, let's see what we get. We get 1.3. So that tells us that D must be right here. And that the distance right here is 0.2. And you could use another one if you wanted. You can also use like a D to C, which is 2.3. You'll notice, by the way, it is 2.3. So that works out great. So then we can go to E. So we see that B and E right here are 2 apart. And if we look at B and C, we could look at B. We could look at any of the other ones at this point. It doesn't really matter. B and E are 2, and B and C are 1. So if we see here that B and E are going to be 2, but B and C are going to be 1, that tells us that we're going to put the, actually, sorry, my fault. Let me rerun that one. So actually B and E, and then not this one. I obviously want to do C and E, my bad. Oh, duh, also 1. That's why I got confused. So C and E, we're going to put E right here because we know that C and E is 1 and B and E is 2, and this also works for that. So everything's cool there. That, by the way, is 1.0. Make that not look like a 10. It's 1.0. That's an ugly, ugly 1, buddy. That number right there, 1.0. Shouldn't have used a Sharpie. Oh, I did it again. There you go. Okay, good. So now the last we have is F. So we know that E to F is 5.5. So that means F could be way the heck out here, or it can be on this side. Let's see what F is to A. And A to F we can see is 2. So that tells us that F is going to be over here. And that the distance right here is 2.0 because A to F is 2.0, but E to F is 5.5. And if we add all these together, we're going to get 5.5. Yes. So therefore the final product, and by the way, you can leave it the way it is, but to just give you like a clearer picture, it's basically F, A, D, B, C, and E with 1.0 here, 1.0 here, 1.5 here, 0.2 here, and 2.0 here. And that makes sense because the farther apart genes are, the higher percent chance you have of having crossover during meiosis 1 and having these genes separated, thus giving you a higher percent chance of offspring that are gonna show recombination. And obviously, A to D, the only way that you could see recombinants in this case is if that chromosome were to cross over literally right here. And that's a pretty small chance for that to happen. And so that's why that recombination is small. So hopefully that video helped. It's just a short video to show you how to take your recombination frequencies from crossover and map them for distances apart. Alrighty, see ya.